Welcome to March's Business of Alt Protein webinar. Today's seminar will feature a presentation by Emily Fenwick on best practices for working with the U.S. National Laboratories. And my name's Molly O'Donnell. I am the policy lead for public investment and industry here at the Good Food Institute. My work focuses on identifying, communicating, and catalyzing U.S. public investment for alternative protein scale-up and commercialization. That means that I engage with U.S. policymakers, track public funding opportunities, and develop resources to support industry stakeholders in accessing public investment. If you're interested in learning more, please reach out. I love to talk with companies about the public investment landscape, have developed a lot of resources to support you all in navigating public funding. And one resource that I'll call out right now is our public funding listserv, which Amy will be dropping in the chat. You can sign up for this listserv and basically get alerts when new grants are released for alternative protein companies, and also learn when we develop new resources, like the resource we're going to be talking about today, our guide to working with the National Laboratories. Again, really to support you all in navigating and accessing public investment. So before I turn things over to Emily, just a few items to run through. First, if you're new to our work here at the Good Food Institute, we are an international nonprofit. We work to unlock the knowledge and resources to transform how meat is made, satisfying rising food demand in ways that accelerate climate progress, protect animals and ecosystems, and strengthen public health. In short, our goal is a thriving world that's fed sustainably. And second, this webinar will be recorded. It will be posted to our YouTube channel. We will email everyone who has registered a copy of the recording, a copy of the slides, some extra resources that may be useful. And lastly, we will have time for Q&A after the presentation. Please ask your questions in the Q&A box rather than the chat. This will help us keep track of them more easily, so thank you for doing that. And you're absolutely welcome to ask questions throughout the seminar, and we'll answer them at the end. So with all that out of the way, it's my absolute pleasure to introduce Emily Fenwick. Emily is a contractor with the Good Food Institute and formerly the Capital Planning and Strategic Programs Administrator at the National Laboratory of the Rockies. During her time at the lab, she worked on strategic initiatives and federally funded research investments, supporting partnerships between government, industry, and research teams. Emily specializes in building cross-sector partnerships across public, private, and nonprofit sectors, and advances work in environmental stewardship, education, and recreation. She recently collaborated with us on producing a guide to working with the National Labs for Alternative Protein Companies. Again, this will be sent to you via email and shared at the end of the webinar. And if you're watching us in the future on YouTube, you'll be able to find the guide in the description. And today, Emily is going to cover the key points of that guide, including an orientation to the National Lab Network and best practices for working with the labs. So Emily, welcome. Thrilled that you're here, and I will now turn it over to you.
Great. Thank you for the introduction, and I'm happy everyone is able to join today. We'll just get right into it. So a little bit about myself, the goal of this webinar, and some context before we really dive in. As Molly introduced me, I did used to work at the National Renewable Energy Lab, now the National Lab of the Rockies, right? With administrative changes, titles and priorities seem to shift with each presidential election. There, I supported lab planning and performance management for nearly 5 years. In that role, I was focused on strategic initiatives. So I was tracking the performance of those initiatives, partnerships, and I worked with our tech transfer offices and partnership offices, reporting up through our executive leadership team and the Department of Energy. So a lot of cross-sectional work when I was at the lab. While I've not personally run any alternative protein projects through these pathways, I have seen how private partners successfully engage with labs, how projects are scoped, how agreements move, where things really slow down, and what actually leads to productive outcomes. This is an informational webinar designed to help you make good decisions quickly. And the goal is not to turn you into an expert, right? We have this resource to provide to you after the fact, but more help you understand the available pathways and leave you knowing what your next step could and should be if labs are relevant to your work and your company. Lastly, it's important to highlight that the National Lab ecosystem, like all federally funded systems, evolves over time and can be influenced by changes in administration, budgets, and policy priorities. So the examples and pathways discussed today reflect publicly available information and practical experience that I've had, but specific programs, timelines, and priorities are shifting constantly. Therefore, please confirm details directly with lab partnership and tech transfer offices if you plan to engage with the National Lab. Additionally, I also want to respect everyone's time and highlight the information that this webinar will cover and the corresponding guidance document that you'll be provided. This is really tailored to startup and growth stage companies, companies working to solve technical bottlenecks like strain performance, downstream processing, analytical validation, scale up, techno-economic analysis, life cycle assessment, or process optimization. Now, that's not a comprehensive list, but from the research I've done about your scope of work, that's where the overlap really resides. Also, that maybe you have a few months to plan ahead. If you're looking for a quick fix and quick answers, working with the National Lab probably is not for you, but this information may still be relevant. And then also, if your focus is primarily like consumer branding and go to market and not really technical R&D, this may not also be relevant for you as well. I'm going to take a sip of water because it's dry here. At the conclusion of this session, you should leave with the ability to identify a national lab that's a strong fit for your company and maybe when they are not a strong fit. Understanding the 5 pathways that companies can use to engage with national labs. Knowledge on which labs and capabilities are most relevant to alternative proteins. The know-how to select a partnership model that matches your goals, your timeline, your budget, and your IP needs. And maybe a 30 to 60-day action plan to get some momentum if you say, yeah, I think I want to work with a national lab. Great. Now that the expectations have been set, here's where we're headed for the remainder of the hour or so. We're going to dive into what national labs are and why they matter to alternative protein companies, where labs fit in the startup life cycle, which labs are most relevant to your sector and what they are known for, the 5 pathways of partnership and how to choose the right one, real examples of how companies have used labs successfully. This is not a new thing. Alternative protein companies have worked with labs in the past. And that practical 30 to 60-day playbook for getting started. And then, as Molly mentioned, we'll have some time at the end if there's any Q&A. And if there aren't any, or there's no answers I can provide to you at this time, because I've been out of the lab network for about 6 years now, I will do my best to answer your question offline and get your contact information at that time. Great. So some quick facts on the National Lab Network. There are 17 U.S. Department of Energy national laboratories across the country. They are federally funded research and development centers, which means they are mission-driven institutions designed to tackle large, complex technical challenges. What matters for this audience is that these labs are allowed and often encouraged to partner with industry. There are formal, well-established pathways for companies to work with labs, access expertise, and use specialized facilities. This isn't special access or back channel work. This is how the system is designed and what is meant for. One important expectation set early on is timing, right? Formal partnerships and agreements typically take about 6 to 12 weeks minimum to put into place. That reflects contracting and legal review. And while it's slower than hiring a consultant, for example, it's fairly predictable once you start understanding the process and is easily repeatable. Finally, not all labs are the same, even though it's a network, right? A subset of labs have pilot scale and analytical capabilities that are directly relevant to some alternative protein companies, while other labs will absolutely not align with your goals. So why would an alternative protein company even consider working with the National Lab? The first advantage is access to world-class infrastructure without massive capital investment. Many labs have equipment that could be cost prohibitive for a startup to build or buy on its own, And instead of investing millions up front, you can access these capabilities when you need them. The second advantage is the people. National labs are home to mission-driven scientists and engineers who are working on foundational problems in bioprocessing, bioenergy, materials science, and computation. When you partner with a lab, you're not just renting equipment, you're actually tapping into technical expertise that is built over decades. And from my experience working at the lab, people are there for literally decades. Third, labs can help de-risk technical scale up. This is especially relevant for alternative protein companies moving from bench scale toward pilot or commercial relevance. Labs can support validation work, yield optimization, cost and performance modeling, and generation of high quality data that holds up under investor and regulatory scrutiny. And finally, when used strategically, labs can accelerate R&D timelines. Instead of relying solely on trial and error, you can use lab capabilities to answer critical questions faster, which can save months, if not years, off of your development cycles. The key point here is that national labs are powerful when they're deliberately used to solve specific technical problems and not just used as a generic outsourcing solution. As you can see here, this map shows the 17 DOE labs across the country. This is a distributed national system, not a single one. The Department of Energy oversees this network, and each lab has a distinct mission instead of technical strengths. Collectively, they work across areas like energy systems, manufacturing, environmental science, advanced materials, as I mentioned, computation and biosciences, all which intersect in different ways with alternative protein development. Structurally, national labs are federally funded research and development centers, most government owned and are contract operated, which means in practice, they operate under federal rules and their missions, but their day to day is run by scientific and technical organizations with deep expertise. The key takeaway here from this slide is that you don't need to engage with all 17 of them or even understand all 17 of them. Success usually comes from identifying a couple of the labs whose capabilities align specifically with your technical needs and engaging in the right partnership model. For alternative protein companies, there are really only a handful of labs that consistently rise to the top because of their scope and capabilities with technical challenges your industry faces. Starting with the lab I worked at, the National Laboratory of the Rockies in Colorado. This is probably one of the most relevant labs if you're working in fermentation or bioprocess scale up. They have pilot scale infrastructure, including fermentation and downstream processing, and a strong expertise in techno-economic analysis and life cycle assessment. Lawrence Berkeley National Lab in California is another anchor lab in your space. Through groups like the Joint Bioenergy Institute and the Advanced Biofuels and Bioproducts Process Development Unit, you'll also see labs and the federal labs have a lot of acronyms. That facility is particularly strong in microbial systems, metabolic engineering, and pilot fermentation. Companies working on precision fermentation or novel microbial platforms often look at Lawrence first. The Pacific Northwest National Lab in Washington is a bit different. Their strength is less about scale up and more about deep analytics. If you need proteomics, metabolomics, imaging, or molecular level validation to understand what's happening inside your system, PNL is especially strong in this area. Argonne National Lab in Illinois is best known for its leadership in life cycle assessment and techno-economic analysis, as well as computational modeling. This is the lab companies often turn to when they need rigorous, defensible sustainability or cost narratives that stand up to investor or regulatory scrutiny. Oak Ridge National Lab in Tennessee rounds out this group with strengths in synthetic biology, systems modeling, advanced manufacturing. It's particularly relevant if you're working at the intersection of biology and engineering. There are other labs with emerging or adjacent capabilities, but for most alternative protein startups, these 5 are the ones I've identified that are likely the best match for your needs. Now, national labs are most valuable as a bridge between very early lab work and commercial execution. They're not typically where discovery starts, and they're not where products get manufactured at scale. On the left here is early discovery and benchmark or bench scale R&D. This is usually best handled by your internal teams, academic collaborators, or small service providers. It's fast, it's flexible, and it's relatively low overhead. In the middle is where you will want to engage with national labs. And it's where the national labs shine. Validation, scale up, and de-risking. This is the phase that you're asking harder questions. Can this process scale? What are the cost drivers? What does the data look like at a pilot scale? Where might this break? Labs bring pilot equipment, specialized analytics, TLCA expertise, and experienced engineers to help answer those questions before you make irreversible bets, right? A lot of de-risking with national labs because of their credibility. On the right is the full commercialization or commercial manufacturing, which typically happens with contract manufacturing organizations, CMOs, or your own facilities, right? We want to be kind of in and out with the labs in that partnership. Labs are not designed to be long-term manufacturing partners. Just kind of get things off the ground and then you're running on your own. The key point here is that labs don't replace your team or your manufacturer. They give you leverage at the moment that the next steps may feel risky or out of reach. If you use national labs at the right time, they can significantly reduce uncertainty before you decide to scale up. There are 5 primary pathways companies use to work with national labs, and you don't need to memorize them all. The goal is just to understand that there are different doors depending on what you are trying to do. Some pathways are designed for shared publishable research. Others are built for proprietary fee-for-service work. Some are about accessing existing IP, and one is focused on very early stage company formation. Over the next few slides, we'll walk through each pathway to help you determine when it makes sense and what to look out for. We'll start with user facilities, because this is often the first exposure people have working with the National Lab. At a high level, user facilities are federally funded shared scientific resources. They're designed to give universities, startups, and industry access to large-scale or highly specialized tools that would be difficult or impossible to build on your own. There are 2 main access models to be aware of. First is the merit review process. In this model, you submit a proposal that's evaluated on scientific or technical merit, and if it's accepted, you often can access that facility at little or no cost at all. The trade-off is that work is generally expected to be publishable or shareable with that lab. The second model is proprietary access. Here, companies pay the full cost of using the facility, but the results remain confidential. This option is useful when IP sensitivity matters, even at an early stage. In terms of when user facilities are a good fit, they tend to be strongest for analytical testing, advanced characterization, and early validation work, especially when you need high-end tools or expertise, but aren't quite ready to invest in building that capability in-house. For alternative protein companies, this might look like validating performance at small scale, doing deep molecular or process analysis, or answering early technical questions that inform your next development step. The key takeaway is that user facilities are about access to tools, to data, to expertise, and they work best when you're comfortable with either sharing results or clearly defining what needs to stay proprietary. The next pathway are CRADAs. Excuse me, which stands for Cooperative Research and Development Agreements. This is one of the more collaborative and most understood ways to work with the lab. At its core, a CRADA is about joint R&D. Unlike user facilities, where you're primarily accessing tools, CRADAs are designed for situations where both the lab and the company are actively contributing to science. The lab brings staff time, expertise, facilities, and equipment. The company typically contributes to funding or in-kind support. The key feature of CRADAs is how IP is handled. Often because the work is co-developed, IP is generally created jointly and in terms that are negotiated up front. Companies often receive rights to commercialize the resulting technology, but this requires comfort with IP discussions and alignment early on. This pathway works best when you're trying to co-develop something new, a strain, a process, a method, or even a tool, rather than execute a tightly scoped task. It's fundamentally about invention together, not buying a service from the lab. So creatives tend to be a good fit if you're comfortable collaborating closely with lab scientists, navigating IP terms, and thinking of the work as a shared scientific effort. If really what you want is speed, clear IP boundaries, and a very definable deliverable, creatives are often not the best choice, right? They're a little bit slower, a little bit more muddied IP, and just really a scientific endeavor as a partnership. The next up are strategic partnership projects, or SPPs. These have been retitled over and over the years. I think it's still called an SPP today. Um, for many startups, this ends up being the most straightforward and attractive way to work with national labs. SPPs are essentially a fee-for-service model. You pay the lab to perform a clearly defined scope of work using their facilities, equipment, expertise. The work is governed by a statement of work with agreed upon deliverables, timelines, and costs. The one reason startups like using SPPs is confidentiality. Unlike the other pathways, SPPs are designed to keep the work proprietary, and companies typically retain ownership of the results subject to negotiated terms. That clean IP boundary is a big deal for many teams. SPPs are especially well suited for pilot scale runs, process optimization, and analytical validation. They're also commonly used for economic analysis T that was been brought up before, and life cycle assessment, where you want rigorous, defensible data. This pathway is also used for work that sits adjacent to food safety or regulatory validation, where you need credible data but can't afford the uncertainty around disclosure. The simplest way to think about SPPs is this. You're not co-inventing with the lab, you're hiring them to help you answer a very specific question, a specific technical question, using capabilities you don't have in-house. The next pathway is technology licensing, and this one is fundamentally different from the other ones we've talked about thus far. With licensing, you're not paying the lab to do the work. Instead, you're licensing existing lab-developed technology. Things like patented organisms, bioprocessing methods, analytical tools, or software that was developed with federal funding. This pathway is used when a lab already has IP that closely aligns with what you're building, and you want to skip or shorten early R&D. Rather than reinventing something internally, you're gaining legal rights to use and commercialize that technology. Licensing agreements are typically handled through the lab's technology transfer office, or I'll call it tech transfer office, and terms can vary depending on exclusivity, field of use, and commercialization plans. Some licenses are exclusive, while others are non-exclusive, and most involve milestones or royalties. Technology licensing works best when you have a clear commercialization path and you know exactly how the licensed technology fits within your product or platform. And now the final pathway I want to cover is the Lab Embedded Entrepreneurship Programs, or LEAP. Some of you might be familiar with this program or even participated in this program in the past. This pathway is very different than what we've discussed thus far. LEAP programs embed entrepreneurial teams inside a national lab environment, typically for around 2 years. Rather than treating the lab as an external partner, your company becomes part of the lab ecosystem, has sustained access to facilities, mentors, and even technical support. Really, really embedded in there. This model exists specifically to de-risk hard technical problems. The kinds of challenges that are too early, too capital intensive, or too infrastructure heavy to solve with a startup company in a startup environment. The LEAP program can help with these things. There are several well-known LEAP hubs, or what they call them as nodes, in the National Lab Network. So if you hear nodes, it just means a hub across the National Lab system, including Cyclotron Road at Berkeley National Lab, Chain Reaction Innovations at Argonne, Innovation Crossroads at Oak Ridge, and Westgate at the National Lab of the Rockies. Each of these nodes or hubs All right, each of these LEAP programs has its own focus and selection criteria, but they all share the same core idea, giving founders time, space, and resources to tackle deep technical risk. LEAP tends to be the best fit when technical risk is very high, when you need ongoing access to special infrastructure, and when the work isn't yet investor ready. It's not designed for companies that already have a clear commercial pathway or just need a single project executed. The fastest way to choose the right engagement model is to start with your goal, not the mechanism, right? So here are 5 pathways. If your goal is analytical validation or advanced characterization, a user facility is often the right place to start. You're accessing specialized tools to answer very specific technical questions. If your goal is a joint invention or co-development with the lab, where you want to build something alongside lab scientists, this is where CRADAs probably make the most sense. If your goal is proprietary development with clear deliverables, especially when IP and confidentiality matter, strategic partnership projects, or SPPs, are usually the best fit. If your goal is to adopt existing technology quickly rather than doing new R&D, then using technology licensing can help you stand on work that's already been done. You don't need to reinvent the wheel. And finally, if your goal is deep technical de-risking for a very early venture, especially when work isn't investor ready, a LEAP program is probably the right bucket. There's no single best pathway. The right choice depends on what you're trying to accomplish right now, and the choice may change as your company evolves. Now that you have a sense of which pathways may fit your goals, let's talk about what it actually looks like to engage and how to avoid common pitfalls. Once you've identified the right engagement model, the question becomes, what does it actually take? What does it take to get the partnership off the ground? This can feel like a mountain to climb, especially working with, a federal entity, right? And the red tape and bureaucracy, but it's actually not that bad. At a high level, the process follows 4 phases. The first phase is scoping. This is where the most successful partnerships are either set up for success or failure. The goal here is to clearly identify your technical bottleneck and define what success looks like. This is when you also need to explore lab capabilities, use resources like the DOE Lab Partnering Service. This is a website that's in the guidance document and report that you'll get at the end and will be posted on the website. The DOE Lab Partnering Service has the whole lab network and outlines kind of all the user facilities, the partnership options, etc. That'll be your hub. Also specific technology transfer office, tech transfer office at the lab level, specific labs, and then of course individual lab websites. You can make initial outreach to confirm alignment. You can call tech transfer offices, the partnership offices too, be like, this is what I'm thinking. These people that work within these offices have done these hundreds of times. They will be able to say yay or nay, this is a good alignment, or even direct you to a different lab that might be better suited. The second phase is putting an agreement in place. This is where you choose the partnership type, define deliverables and timelines, and also review your IP terms with counsel. One thing that's critical here is assigning clear points of contact on both sides. Labs are very large organizations, and clarity can save tons of time and reduce a ton of friction. So have one person on your team be that point of contact to have that one point of contact on the lab side as well. The next comes execution. This is the project work itself, running experiments, managing milestones, and maintaining regular communication. And the teams that get the most value out of the labs are proactive here, have proactive project or program managers on your side. They leverage lab scientists as collaborators, not just service providers. And remember, when you're working with the lab, this is something that came up often when I was there, is these people are scientists, not all of them are project managers. And so they love doing the science, they love doing the research, but where they might not be as strong suited is managing the project itself. That's where your companies and potentially your teams can actually help the labs progress through these partnerships. The final phase is follow-up. Depending on the pathway, that might include disseminating results, deciding on next phase work, or maintaining the relationship for future projects or funding opportunities. Labs are relationship-driven environments, and strong partnerships often compound over time. The key takeaway here is that working with labs isn't a one-off transaction. It's a process. When you approach it deliberately, it becomes much more predictable and effective. I want to be candid on what actually slows down lab partnerships, because that's most of the frustration. Most of the frustration that people experience is predictable, right? So you should know this getting in. Things just take a little longer working with a national lab. On the left-hand side of this slide here are the usual culprits of what slows stuff down. Contracting and legal review takes time on both sides, but definitely on the lab side for sure, because labs operate under federal requirements. IP negotiations is another common slowdown, particularly if expectations aren't aligned early. Facility scheduling and staff availability matter too, right? If there's high demand for a certain capability, a user facility, or even specific scientists, that just might delay your timeline. These are shared national resources, not on-demand services. Security and site access can also add to lead time, and timing around the federal fiscal year can unexpectedly stall process, right? As we saw, we've had waves of layoffs over the last 12 months or so. People that were in partnerships with scientists or certain areas might have seen things slow down within their projects or even getting a project stood up and put in place. The good news is that most of this is totally manageable if you plan for it, right? On the right side are a few ways teams can successfully reduce the friction. One is starting as early as possible and just assume it's going to take longer than you think, right? Definitely longer than in the private sector. Also, assigning that single internal owner on your team to coordinate paperwork and inputs can make a huge difference. Writing a clear scope of work with defined deliverables and success metrics helps avoid rework later. That's where if you can provide a project manager, even better. And finally, early exploratory calls with tech transfer or partnership offices are incredibly valuable. They will let you, or they will validate fit before anything formal gets drafted, which can save you months. Leverage those experts in those offices before you take any steps forward. None of this is meant to discourage engagement. It's really just meant to keep or get your eyes open and avoid the most common traps. I do want to leave you with a few best practices that I have seen that made a real difference in lab partnerships over the years I was at NREL or NLR now. First is alignment with federal priorities, and that matters a lot. Labs don't operate in a vacuum. Framing your work in terms of DOE, Department of Energy objectives like energy security or domestic manufacturing, right? High priorities right now for this administration can dramatically improve receptivity to the partnership. It's also worth keeping an eye on policy shifts because priorities do evolve across administrations. Second, leverage institutional knowledge early. Tech transfer and partnership staff have seen hundreds of projects. They can help you understand what's realistic, what's been done before, and even where proposals tend to get stuck. The third is build in lead time. CRADAs and SPPs aren't fast, and that's totally normal. Expect 6 to 12 weeks minimum, sometimes more, to get something in place. Clear scopes of work and define deliverables, milestones, timelines, and roles will save you time later. And finally, think strategically about partnerships. Labs also partner with universities and nonprofits, and those partnerships that you might put in place ahead of time before engaging with the national lab will strengthen your proposals and potentially even open up funding pathways, such as the Small Business Innovation Research and Small Business Tech Transfer grants and ARPA-E, Advanced Research Project Agency, Dash Energy grants to help meet eligibility requirements that startups can't meet alone. So keep networking, keep partnering, and that's what the labs are really looking for in developing these relationships with you. I just want to spend a quick moment here, but not go deep into any specific one. This is also in the report that you'll be provided at the end of our session today, but just want to make a simple point. That these pathways I've outlined are not theoretical. They're already being used with alternative protein companies and adjacent to alternative protein space today. Across these examples, you'll see a few patterns. Companies use labs to scale fermentation, validate processes, access pilot facilities, or de-risk tech or early technology, often moving from lab scale to something investors or customers could take seriously. The specifics vary, and I'm not presenting this as a blueprint by any means, but the takeaway is that startups like yours are currently successfully working with national labs across different engagement models. And the mechanisms we've talked about today are the same ones used here. So you can see most of these are CRADAs, couple SPPs, and then we have the Umara one here that was in the LEAP program. This slide is less about grants and funding and just more about signals, right? Because these are things that are shared on National Lab website and the DOE website. If you take one thing away here, it's that most valuable information usually shows up before funding opportunities open. Requests for information, workshops, listening sessions, and early program language are how DOE and the labs test ideas and shape what's coming next. That's kind of why NREL got this rebrand this year. What was next was, oh, we're broadening our scope from renewable energy to also branching out into manufacturing focus, hence the rebrand. So there were some signals going on that that change was coming. If you are paying attention to the National Lab Network, you can see where priorities are going, especially around biomanufacturing, scale-up infrastructure, and domestic production capacity. However, don't treat funding as the starting point to engage with a lab. The strongest partnerships usually exist before solicitation is released. Funding then just becomes a way to formalize or accelerate the work you already know makes sense to partnership with the lab. For startups, if you have the capacity to do so, that means tracking themes. If you see a repeated emphasis on a capability you might need, that's your cue to start a conversation with labs now. Don't wait, because that demand might grow and you'll be in competitiveness with other people that want to use that facility or those scientists or that expertise. And finally, not every company needs to apply for every program. Sometimes the most strategic move is simply knowing what's coming, aligning your strategic roadmap accordingly, and being able to move when the right opportunity shows up. So just keep a pulse on the administrative priorities, DOE priorities, and just kind of what things are they emphasizing on their websites or press releases. That'll help you align your proposals and get engaged quicker. If working with the National Lab has piqued your interest after this presentation, here are a few actions that you can take in the upcoming month or two. Step one is defining your bottleneck. This might sound obvious, but this is where usually teams overscope, right? They'll come to lab with like this big grand vision and it will take forever to get something off the ground. So the more specific you can be, the more specific technical problem that's holding your commercialization back, the better. What data or result would actually reduce the risk for your investors, your partners, for your manufacturing? So define your bottleneck. Step two is shortlisting one or two labs, right? There's 17 of them. So you need to identify which labs are most aligned with the things you need. Focus on fit, capabilities, facilities, and whether a lab has worked on something in this space specifically or adjacent before. You're looking for relevance, not prestige of the lab. Step three is an exploratory conversation. Reach out to those lab-specific technology transfer offices and partnership offices and ask who the right technical lead might be based on the bottleneck or specific technical question you have. The goal here is to validate fit before you spend any time drafting anything formal. Don't waste your time before you know it's the right fit. Step four is choosing your engagement pathway. This decision should be driven by how sensitive the IP is, how quickly you need results, and what level of budget you're working with. So IP, speed, and budget. Those three things, they'll be important to you to determine that partnership model. By this point, the right pathway usually comes pretty clear. And finally, draft a simple, I can't emphasize simple enough, simple scope of work. Keep it practical. Clear deliverables, a realistic timeline, and defined roles. You're creating alignment, not a perfect contract on day one. If you can move through these 5 steps over the next 60 days or so, you're no longer just thinking about working with a national lab. You're definitely on the path. As we wrap up, I want to make this feel very tangible to everyone here today. And if there's one message that I hope sticks, it's that engaging with a national lab doesn't have to be complicated or slow to start. You don't need a fully formed proposal or a perfect plan, just a tight one. A great place to begin is the Lab Partnering Service, LPS. This is the system partnering service, right, across all 17 labs that provides kind of a high level overview of the capabilities and models that they have. It's essentially a front door to the lab system, a way to explore capabilities, understand what exists, and identify where there might be alignment. From there, it's completely appropriate to contact the lab specific technology transfer office or partnership office. Labs have different ones and different naming conventions. Ask for a short exploratory conversation. The goal isn't to sell them your company, it's to validate whether the problem you're trying to solve is a fit for how the lab operates and identify maybe the right engagement model with that lab. And then finally, I'd encourage you to think about labs as just not a one-off project necessarily, but part of your broader company strategy, right? How can you get them involved? When used intentionally, they can really be a strong lever, helping you de-risk key steps in your commercialization roadmap and move faster with more confidence. I'll close with a few key takeaways, just anchor everything we've covered. First, national labs are a real and usable resource for alternative protein companies. They're not just for massive corporation or government only projects, but they do require engaging in the right way. The best outcomes from choosing the right engagement model and scoping tightly. Labs are incredibly powerful when they're applied to a focused problem and clear success criteria. It's also important to expect some administrative friction and that you plan for it, timeline wise and emotionally, right? It's not the reason to avoid labs. It's just part of working within a public research system. Teams that succeed build in time and assign ownership of tasks. Starting early matters. Alignment with national lab priorities, having one internal owner who can move things forward makes a real difference. Get that project manager in place. And finally, when done well, a lab collaboration can meaningfully reduce technical risk, accelerate scale up, especially at moments when the next step feels maybe too expensive or too risky or too complex to do alone. And with that, I am happy to answer any questions on kind of a strategic or practical level. As I mentioned, I've been out of the lab system for a good amount of time, and that system has seen a significant amount of change in just the last 12 months. And if there's something I cannot answer, we'll definitely flag it, and I'll work with the GFI team to get that answer to you or point you in the right direction as best I can offline. Thanks.
Thank you so much, Emily. That was an incredibly helpful presentation. And we'll ask as well, Amy, if you could drop the link to the guide in the chat. Folks, please feel free to reference that. We're happy to take some questions now. Have a couple here already. But also, if you have questions, as you're going through the guide, feel free to email me. So first question, do you have a sense of which labs have the strongest track record of commercial partnerships, rather than government to government partnerships around scaling industrial and manufacturing processes versus labs who lean more research focused? This person notes they're near PNNL, just for added context.
I don't know off the bat. I do believe the National Lab of the Rockies, because I can see it from my house, is building a new manufacturing facility. I believe that's what they're focused on. I haven't done a deep dive into that, But that's where the lab partnership service office the website can help you do a deep dive into more of those manufacturing hubs.
Awesome. Yeah, and you did respond to this, I think, but maybe just want to yeah, highlight again. So there was that really helpful slide with the breakdown of the lab capabilities that are most relevant to alternative proteins. You had mentioned this lab partnership service, the hub, but just to kind of answer cleanly again, like how can companies find a breakdown of what each lab offers sort of in one spot?
And the lab partnering service website, LPS would probably be the best website to dive into that.
Great, fantastic. Yeah, and we do have some more, this is all spelled out a bit more clearly in the guide as well. If you want a bit more in depth on kind of the labs that have worked with companies and things like that. So definitely that can be a good starting point to help navigate as well. Um, so we got another question here around UPFs, ultra processed foods, how the current administration views ultra processed foods and alternative proteins. I'm happy to take this one first, and then Emily or Pat, if you have anything to add, feel free to jump in. Yeah, there's been a ton of talk around ultra processed foods lately. There is no, formal legal definition for what an ultra processed food is. Last year, FDA did release a request for information, seeking industry input and scientific input on how ultra processed foods should be defined. And GFI did respond to that along with the Precision Fermentation Alliance. Our comments really focused on, ensuring that healthfulness and inclusivity were, considered along with the sort of processedness of the food, that nutrition of food was not kind of lost in an ultra processed food definition. So, yeah, just wanted to address that. I'll drop that comment in the chat, and our regulatory team's also happy to answer any further questions on that if folks want to email me after the fact. I will say I don't, I see that as somewhat separate from, the national labs kind of partnering around their initiatives around bioprocessing, domestic manufacturing. But I think it's definitely, yeah, an important point, something that folks are talking about a lot in Washington. So yeah, anything else to add on that, or we can move on to the next question.
I don't have anything significant, but you might be surprised of like, I know I was always exposed to research that wasn't always, I don't know, apparent and obvious on, on the lab websites or things that they're advertising in publications. But food research, for example, happens in smaller pockets. It just not as a bigger emphasis where I'd be like, why would the National Renewable Energy Lab be worried about food? I'm like, oh, they're doing food research projects and sustainable agriculture, those types of things at the National Renewable Energy Lab. So the labs, even though they might not outwardly, advertise or highlight those capabilities or that research, that's when you might have those exploratory conversations with their tech transfer office or partnership offices because it not might not always be so obvious with just online research.
Mhm. Thank you. That makes sense. Another question here. Could you talk a bit more about the funding for national labs? And so I understand, there is some federal funding that comes out of DOE, out of their appropriated budget. And the national labs also have, fee for service, as you spoke to. What is kind of the balance of that?
Unsure what the current like split is, but typically the way, at least when my time at the lab was there, is I was in charge of like three buckets of money, right, of the funding. And in partnership with the Department of Energy and the executive leadership team of that lab, we would get proposals internally from scientists working with, private industry, nonprofits, et cetera, and the Department of Energy and the executive leadership team would prioritize those proposals and fund them on a stage gate process, depending on, how well that project was performing over time. Um, I don't know the split or percentages of what those ratios are now, but that is typically the internal process. When we're talking about leveraging partnerships, right? If you partnership with a university or an academic institution, those federal funds are just a lot more, I guess, more justified, and you'll get a higher priority to get funding. Um, but I don't have the split or kind of the transparency on the budgets today.
Uh, Yeah, no worries. I think that that overview is super helpful. You know, a variety of kind of funding models can come in, and as you mentioned, really supported by DOE priorities. There is one kind of fun thing I wanted to call out as well, which is Lawrence Berkeley National Laboratory just received an award from Department of Energy to establish a new food innovation center, which really specifically includes alternative proteins and fermentation-derived proteins sort of in the project description. So a little TBD, you know, on how that project's going to play out. It's really just beginning, but I was really excited to see them receive that grant. So we'll drop that in the chat as well for anyone who's interested in reading more. Um, and if you're watching us in the future on YouTube, all of these will be in the description as well. We'll make sure of that. Okay, next question comes from a cultivated meat company. Historically, when we've engaged CMOs that are fermentation facilities, they have been hesitant to work with cultivated meat companies due to a risk of cross-contamination. Do you know if National Labs have similar concerns? And are there any you'd recommend that could be a good fit for bioprocess scale up for cultivated production?
I'm just not sure if there's any concern with cross-contamination. There, I mean, very rigorous lab environments and lab facilities. That being said, my best guess is the National Laboratory of the Rockies here in Colorado is probably the place I would start and ask those questions because they do have kind of the integrated biorefinery research facility, right? And I think that has got a lot of traction over the last 5-ish years. And so that's where I would start and have that exploratory call.
Great, thank you. Another question here, it probably varies project to project, may have also, you know, changed even since your time at the labs, Emily, maybe varies from lab to lab, but are you able to give a sense of sort of roughly for the SPP model what the fees could look like? And I think the question behind the question is a lot of companies in our space tuning in are really early stage, really bootstrapped, you know, wanting to know how accessible that model is for them.
Yeah, I am unsure of what the fee for service costs are, especially these days. That being said, right, there are the different pathways where if you have those partnerships and I can scroll anymore in place where you can get resources for free, right, with certain other pathways. Um, so unsure of the costs. I think it depends on the scope significantly and what facilities and user facilities you're looking to use. And then also, you know, costs can be really low if you're willing to share that IP and it's a joint venture. So I think there's a kind of a wide gamut. I know that's a non-answer, but I think it really depends on the specific scope of work.
Great. Makes sense. Thank you. Um, Another question here, which I'll take a first stab at. Do other nations have IP and financial support for US based innovators? You know, I will say I am primarily focused on the US. This guide is focused on the US. So I'll first kind of answer the question in reverse. And maybe Emily, you can speak to the reverse for National Labs specifically. But I think in terms of funding opportunities, it actually really does depend on the specific opportunity and the specific agency. So, Department of Energy, most of their funding opportunities, if you're a foreign company that's seeking funding for work that's going to be done in the US, like you can reasonably expect that US government agency is funding work that will happen in the US. But foreign companies can, there's like a waiver process that you essentially apply to participate. That's for Department of Energy. Defense is a little different, can be pretty widely scoped. Actually, a lot of foreign companies can work with the US Department of Defense for some opportunities. It can be, you know, just Canada, Australia, the UK, and the US. So really does depend. And final thing, I think to actually answer the question that was asked around other countries, as I mentioned, I focus on the US. GFI, we're a global network, so we do have offices in other regions that are working on developing out this type of work stream that I'm doing, which is like identifying and communicating government funding opportunities. So I think well, I don't have a specific answer around, other countries' funding opportunities. I'd say please sign up for our public funding listserv as we're able to develop those types of, the types of resources that we have in the US for other geographies. We'll be emailing that listserv. So I think that's the best way to stay posted. And sorry, I don't have a more exact answer for you. But Emily, could you talk a bit about, non-US based companies working with US national labs?
Yeah. From my experience, more hurdles to over, right? Bureaucratic hurdles just for security purposes and reasons and partnering with the National Lab and depending on the scope of research and partnership that's being put in place. My time in the lab was highly a lot of international work and a lot of international partnerships. I would say with changes in administration, that's probably been shrunk, but that's kind of a typical life cycle of any national lab. It's kind of like these boom and bust things that we see every administrative change. That being said, it shouldn't be prohibitive to try to establish, a partnership and get the use of those facilities. You just might have additional counsel and paperwork to go through. And it might be harder now than it is with a different administration, just depending on what the priorities and focus are of the DOE at the time. Right now, I think there's a de-emphasis on international work. But my time at lab, there was a high emphasis, right? And that wasn't too long ago. So these cycles are predictable in a certain way. That shouldn't be a deterrent. But when they're more open to international partnerships, you should be ready to strike because that will circle back around again.
Yeah, that makes sense. And we have time for, I think, one or two more questions. So another question is around if you could speak a bit more into some of this administration's strategic priorities for national labs. The previous administration was very focused on decarbonization. I think things have shifted a lot. Seeing like I think biotechnology, bioprocessing is a big theme. Domestic manufacturing. I know you called out some of these a bit on your slides earlier, but could you speak a bit more into that?
Yeah, I think you hit all the major ones minus security. Like security is a big one, hence kind of the making it a little bit more difficult to work internationally on that same theme. So defense security is a big emphasis at our energy infrastructure since these are DOE labs. Granted, they do anything beyond energy too. But everything you mentioned as well, domestic manufacturing, bringing stuff back into the US. Yeah, I think you hit all the marks on that one, minus security being an emphasis. But as I mentioned, there's these pockets within the lab that may not be like super aligned with what's being advertised outwardly by the DOE and their priorities. There's still research going on across the gamut. It just not be might be as highly advertised.
Mhm. Yeah, thanks for that extra context. Awesome. And we are at the top of the hour, so we are going to wrap up there. Big thank you, Emily, for sharing your time and expertise with us today. And thanks to our audience for your participation. Just as another reminder, today's seminar has been recorded. It'll soon be available on our YouTube channel and emailed out to you. And finally, we would love to hear your ideas and feedback. Please feel free to email corporate@gfi.org or reach out to any of us directly. You'll get this post-webinar email coming from me. Feel free to hit reply. I always love to learn if stakeholders are using our resources, how you're using them. That's really helpful for us to know, for us to share with donors. So please we love your feedback. Also, if there are, better ways we could support you, ways that we could improve, please don't hesitate to share any of that with us. And I think that's about it. Thank you so much, everyone, and enjoy the rest of your days.